Okay, probably our most important information that we learned yesterday in leading up to this point when it comes to these reactions. Okay, when you're looking at a compound that's an there's a couple things that we want you to be able to establish. One, is the compound symmetric or asymmetric? Then, what are you reacting it with? A symmetrical type of reagent or an asymmetrical type of reagent? Okay? So, those all play a part in this process of when we go through this, and whether it's a halo, this should be hydrogenation, not hydrohalogenation, it should be hydrogenation. Then hydration. What does it mean when you hydrate something? You're adding what? You're adding water, because if you become dehydrated, that means you're removing water. Okay? So all of these types of reagents, if they're set up just right, the asymmetrical reagent then follows this rule right here. And what you want to establish then is you will attach hydrogens, okay, where there's already the most hydrogens present, okay? We call that Markovnikov's rule. Now, is that confusing? Well, yes, it can be. It's not our first time seeing something very similar to this. And we'll go over a couple examples here on the board, and then the rest of the time will then be given for you to finish your what was given to you yesterday. Okay. So this is really no surprise. These types of reactions you have learned in physical science, combustion type, and we did those in general chemistry, and we don't spend a whole lot of time on that with that organic chemistry. The reason we don't want to spend a whole lot of time on this is we want to wait with this. The aromatic compounds, we're not going to start that until you come back, and that will be next Tuesday. Okay? We really don't want to, again, everything we're talking about now is what we call aliphatic carbons. Okay? In this section, when we're talking about aromatic hydrocarbons, they're attached to what we call benzene rings. Okay? I don't mean to spend a whole lot of time on here. I just wanted to point out that we'll be beginning with this on Tuesday. Okay, so when it comes to alkynes, we know somewhere there is a triple bond. You had alkanes single, alkenes double, and then with no surprise, alkynes then is triple then. Do one more slide, finish up the alkynes. And we really don't spend a whole lot of time on the reactions with the alkynes. We'll show you what happens, and it may be on your evaluation. But we'll cross that bridge when we get there. but what happens is this also follows Markovnikov's rule, and we'll establish that here in just a couple moments. Okay, does everyone have this information that wants it? Yes? Okay. Okay. So when we, let's say, put to use or pick up where we left off with last time, so someone give me an example of an alkene more than 4 carbons. Pentene, okay? And with that pentene, is it 2 pentene? How about 3 pentene? There is no such thing as 3 pentene. Show you why. Yes?
I got this stuff.
Okay.
Is it okay if I spend 6 hours in this concept in this class?
Well, how about you go to class, check in, and come back?
Well, I mean, then I gotta leave more stuff off. I mean, I can come in here at the beginning 6th hour.
I'm gone 6th hour.
Can I take it in Wilmington group?
When's that?
6th hour.
I would prefer not. No, I prefer you to do that while I'm here. Just, I'll come and talk to you after 1st hour, okay? All right. So, this pentene, is it 2 pentene or just pentene? Okay? So, the reason we say that, how many carbons is that? It's 5 carbons. Okay, so we said, is it 1 pentene or 2? We said, well, about 3 pentene. No, that's coming back from this direction. So did you say 1 or 2? 1 pentene, okay? So when we do that, we can establish these bonds in here, okay? So how many hydrogens does this carbon have? Well, it's got 2 bonds to this carbon, 1 bond to that one, so how many hydrogens can it have? Just 1, okay? Then this carbon is double bonded to this one, so how many can this one have? Okay, so either top and bottom or top and side, it really doesn't matter which way you want to do that. And when we establish, is this, and when you talk about this, you got to be careful when you say, is this asymmetrical compound? Is this is why I always say the symmetrical or the asymmetrical. If you said, is this the A space symmetrical? Or is it the asymmetrical? I think there's only one M in symmetrical. My mistake. Okay? So that's why you got to be careful when you're talking about these. Is this the asymmetrical compound or the symmetrical type? It's asymmetrical, okay? So in case you're wondering why we always say it that way, that's why. It's the asymmetrical type, not the symmetrical type. Okay, so now when this reacts with, so give me an example of a reagent, the symmetrical type or the asymmetrical type. want an example of the asymmetrical compound or example of the symmetrical compound reagent. Okay? So we have our choices. You want this one or that one? First one, okay? And we can write it as HOH. It's easier to see that. Okay? Does this need a catalyst then? Does this need a catalyst? No, it does not. Okay, so when this reaction proceeds then, okay, this follows Markovnikov's rule then. What that means is since this molecule gets split, that is the asymmetrical type, you can have two products. Okay, so with that, the rule says that the hydrogen will attach where there's already the most hydrogens present. So what that means is, obviously with these three carbons, you cannot attach anything else. This one can have an attachment and this one can have an attachment. So this hydrogen then attaches to the carbon that already has the most hydrogens present where it could bond. So that means it's the first one. So let me color code that, and I think it's easier to see then. Okay. So it's still the same reagent. Okay. So we've got hydrogen, or even maybe color code that too. H and OH. Okay. So now, when this reaction proceeds then, it's going to go all the way down to everything is single bonded now. But this hydrogen attaches to where already the most present, or has the most hydrogens present, and you correctly said here. Therefore, leaving the OH to attach to the second carbon. Now we've accounted for everything. Put that hydrogen on there so we can see where it goes. And you have to label this. Is this the minor product or the major product, do you think? This is the major product, okay? So if we're saying we have to label them, well, that must mean we've got a minor product, and that is true. Okay. Which means these two then just get flip-flopped. That the hydrogen goes down there, and then the OH gets attached onto there. So it really doesn't matter, like we said, if you had started with the hydrogens on there, that's fine. It really doesn't make any difference. Just know that there's just two hydrogens on that first carbon, so that when this proceeds, that according to that rule, this hydrogen attaches to the carbon that already had the most, which is this one, making that the major product, therefore making this one the minor product. Okay. Questions on that? It's the middle of the week, people. We can smile. Is it because Chicago lost last night? Colorado beat them in 13 innings? Is it that Minnesota has to travel to Philadelphia this weekend? Is it that Minnesota baseball is done with? You know it's quiet in here when you stand here and you just hear the clock go tick, 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 tick. Now we're bobbing our heads. All right. So what we can pick up on tomorrow is how would we change our first, reactant to the symmetrical type? Because right now it's asymmetrical. So how would we change pentene to the symmetrical type? Do what with the double bond? Just move it over one. Then what happens, okay? Then these just have one hydrogen each, okay? And then it doesn't matter what you react that with, whether it's the asymmetrical type or the symmetrical reagent, it's not going to make any difference, because if you reacted that with water, half of the time you would receive this, and the hydrogens on this one, and then the other half of the time it still has two products, but you don't have to, you just have to give one of them because they form in equal amounts. That's why. Let me double check on that. The most important aspect is this type of reaction. We have the major and the minor product. Okay. So I can find that out right quick. We will pick up with this tomorrow.